5-6, graphing inequalities in two variables. Our essential question today is how do you graph a linear inequality on a coordinate plane? We have three new vocabulary words. The first one is boundary line. The boundary line is the line that you are graphing. So for the linear inequality, much like a linear equation, you can graph the line that is represented by that equation or that inequality. So the boundary line today, it could be a solid line or it could be a dashed line. This is much like when we graph our inequalities on a number line and we have an open circle versus a closed circle. The two symbols that are going to indicate to us the solid boundary line are going to be the same as the two that gave us a closed circle on our number line inequalities. And then with an open boundary line, we have the two symbols that gave us an open circle. Now, an open half plane means that we are going to have an open boundary line and then it's going to be shaded on one side. Shading it on one side creates a half plane. Think about a coordinate plane with an x and y axis. If our solution set was every point on the coordinate plane, that would be the entire plane being shaded. We're talking about a half plane. A closed half plane means that one side of your boundary line is shaded again, and that boundary line is closed. So the open half plane is the dashed line, the closed half plane is the solid line, and each of them is shaded on one side, because shading half of the coordinate plane, that's why it's called a half plane. Okay, so those are our three new vocab words. Now, going back to chapter 4, maybe even chapter 3, we need to make sure that you remember how to graph all of these lines. So the first one is written in slope-intercept form. Remember slope-intercept, what does y equal? Mx plus b. Remember that the m is the slope of our line, or rise over run. And remember that b is our y-intercept, and our y-intercept is on the y-axis, and that's our starting point for graphing. So, I'm going to graph all four of these lines. Notice they're beautifully color-coded to match my markers. So the first line has a y-intercept of -1. So I start on my y-axis at -1. Slope 1 over 2. So rise 1, run 2 to the right. Rise 1, run 2 to the right. So this line has a positive slope, positive 1/2. The red line, I'm going to start at an intercept of positive 4 on my y-axis. And the slope of that one, I'm going to put a 1 under it. So my rise over run, -3 over 1 means I go down 3 over 1 to the right, down 3 over 1 to the right, and then I can draw my line. Okay, now the green line. The green and the blue lines, these two have only one variable in them. Y equals 2. That's the y-intercept. Y equals 2. You may notice that there is no slope in this equation, so it's the same as 0x plus 2. If my slope is 0, my line is horizontal. Every point on that green line has a y-coordinate of 2. My last line, the blue one, x equals -5, that is the x-intercept instead, so it doesn't have a y-intercept, only an x-intercept, and this line is going to be vertical. Every point on the vertical line that I just drew has an x-coordinate of -5, so that is the line x equals -5. So this is a review, because we're graphing again today. The only difference is our equal signs are going to turn into inequality symbols. The effect that that has on our graph is, like we talked about in vocab, we are going to have, with the less than symbol and the greater than symbol, we are going to see dashed lines for our boundary lines. So these are both going to be dashed lines. And then we're going to see some solid lines when we have the equal underneath, whether it's a less than or a greater than or equal to. Those boundary lines are solid because the equal underneath means you include the points that are on that line. You include them in your solution set. Now, the significance of the less thans versus the greater thans. Well, typically, you can think of the less than symbols as shading below your line when it's written in slope-intercept form. And greater than you can think of as shading above your line when it's written in slope-intercept form. Okay? We are going to teach you to find a test point just to check and make sure. So we're not just going to be guessing on that shading piece. You'll see that a little bit on the next slide. Okay, so here we go. My red line says y is greater than negative 3x plus 4. So this is the same line that I graphed on that intro slide. So negative 3 over 1, negative 3 over 1. Notice that I'm continuing this one because I really want to make sure that I've covered the entire coordinate plane here. So I started at 4 on the y-axis and I went down 3 over 1 repeatedly for my slope. Now, I want you to notice that my inequality symbol is just a greater than. So that means that I am going to need to have a dashed line So here's my dashed line. And because it's a greater than symbol, I would like to say that I'm going to have to shade above. So look at where the intercept is right here. Above that y-intercept is going to be up here. So this is the side that I believe I need to shade for my half plane. So this is an open half plane. To check and make sure that that is correct, I'm going to use a test point that is clearly on that right-hand side of my line. So I think this spot right here, this is 2, 2. I am going to check and make sure that that is correct. So now I'm going back over here to my inequality, and I'm going to plug in 2, 2, so 2 for x and 2 for y, and make sure that I have shaded the correct side. So substituted 2 for each of the variables, and we need to check and make sure, using the order of operations, that this is true. So 2 is greater than negative 2? Yes. So I have shaded the correct side. If I got no, then I would know that that is not the side to shade. So if I picked a different point, like this one, 0, 0, if I put in 0 and 0, you'll see that this is not going to be true. Negative 3 times 0 is 0, plus 4 is 4. 0 is not greater than 4. So if you're in doubt, you could take 1 point on each side of the line and see which one is true. So I've shaded the correct side. I'm done with this inequality. The next example. Okay, this one's a little bit trickier because our equation is starting out in standard form. So we need to do a little bit of rewriting first. So if I rewrite this to get the y by itself, we learned how to do this in chapter 2 and in chapter 4. So 3y is greater than or equal to negative 2x minus 6. Remember to write it in slope-intercept order. And then I can divide everything by my 3. So y is greater than or equal to negative 2/3 x minus 2. Go going to group this so that I can make it a little bit smaller. There we go. Okay, so now we're ready to graph this line. So my intercept is -2. My slope says rise over run, -2/3, so down 2/3 to the right. Continue. Reverse that in the other direction because we are looking for a half plane today. This line, this symbol, okay, our symbol has an equal underneath, so that means that it's going to be a solid line. Instead of a dashed line. And I believe because it's a greater than symbol, I am going to shade above. So I believe that this is the correct side. When you're working on your homework, you might want to shade it really lightly, or you might not want to shade it at all until you pick your test point, just to be careful. My test point I'm going to put in is 0, 0 on this one. So if I go to my original and put in 0, 0, the left-hand side, 2 times 0 is 0, so is 3 times 0. So 0 plus 0 is 0. That is definitely not greater than. Oh, wait a minute. It is greater than a negative number. 0 is greater than or equal to -6. So I am correct. So, true. Remember, you can pick a point on the other side. Negative, let's see, 1, 2, 3, maybe -5, -1, and I could check and make sure this one's a no. So 2 times -5 plus 3 times -1 is greater than or equal to -6. -10 plus -3, so -13 is greater than or equal to -6. No. Definitely not. -13, it is more negative, so it is smaller. -6 is closer to 0. So, this one looks good. Now, the next two are going to be horizontal and vertical because we see that we've only got one variable here. So this variable, and I'm solving for, is just x. If I subtract 3 on both sides, 7 minus 3 is 4, and divide by 2, x is greater than 2. So on the x-axis, 2 is right here. This is going to be a dashed line because it does not have an equal underneath the symbol. In this one, it should be pretty easy for you to think about which side, because on the x-axis, where are the numbers that are greater than 2? They're over here to the right. And if I choose something on this side, let's say that I pick this point right here, 4, 0. I'm just going to be putting the 4 in for x. There isn't anywhere to substitute the y. 4 is greater than 2? Yes. So this one is done. The next one, similar to that, only now the only variable that we're using is y. So if I solve this to get the y by itself, 33 minus 8 is 25. Divided by 5 is 5. This symbol is going to give me a solid line. So the y-axis, 5 is right here. There's my y-intercept, solid line. And looking at the y-axis, if y has to be less than or equal to 5, that would mean shading below. Choosing a test point, my 0, 0, favorite point to use. If I put 0 where the y is, 0 is less than or equal to 5, yes. All right, last but not least, a word problem. Okay, write an inequality and graph. PTO promises a pizza party if students sell at least $1,000 worth of pies and cheesecakes. Each pie is $10 and each cheesecake is $15. How many must they sell to get the party? Use the graph to find 3 combinations of pies and cheesecakes that would work to earn the party. Okay, so we're going to use P for pie and C for cheesecake. to set this up as an inequality, I'm going to have to know what to do with all of these numbers, and I need to have an inequality symbol. If each pie is $10, that means I would need to multiply 10 times how many pies you sell. Plus, each cheesecake is $15, so plus 15 times how many cheesecakes you sell. And if we need to raise at least $1,000, my symbol is not going to be less than. I know the word at least sounds like less than, but it is not. We have to earn more than $1,000 or equal to $1,000, okay? So here's my inequality. Now, to graph this, I am just going to pretend like these are X and Y because I know that you like to use those variables instead for graphing. So I am going to get this in slope-intercept form. So subtracting 10x on both sides. And then dividing everything by 15 gives me, if I reduce that fraction, I can divide by 5. So negative 2/3 x plus, I'll go to my calculator to divide this one, 1,000 divided by 15 is 66 and 2/3. 66 and 2/3. I'll double check that. Okay. So now for my graph, I am thinking if we have 66 and 2/3, I probably want to go by tens. Okay, so I'm starting out at 66 and 2/3. So that's going to be about right here. And then it says I'm going down 2 over 3. Down 2 over 3. So that would be the same as going down 20 over 30. So about right here. Down 20 over 30. About right here. So this is what my line looks like. Okay, now we need to pick 3 combinations of pies and cheesecakes that would work in order to earn the party, So if we're going to earn greater than or equal to $1,000, we have to select something up here. So I am going to say, it looks like if we, and on my x-axis this is pie, and then the y-axis this is cheesecake. So I am going to say that any points up here, so I'm going to say like 10, so we could go with 10 pies and 70 cheesecakes, that would work. Then I could move over and say 20 pies, 70 cheesecakes would work. Maybe I want to go with 30 pies, and 60 cheesecakes. So you see that there's kind of an infinite amount of solutions that you can choose from up there, but those are 3 that would work. You should be able to write your summary now, and here's your homework.